Hi everyone. 2.4 is probably going to be kind of a tricky section. We're basically trying to kind of put the pieces together and work with expressions that have a whole mix of our operations. And I would say one of the big themes of this section is going to be trying to see the simpler problem in the mess. I would say that's actually a theme for the whole course. But this first chunk I want to do maybe is kind of like that, but I actually would say it's more of an order of operations question. And there's two ways to do this that I think we mentioned in class earlier, but I want to make sure that you've got them both here. I would say one is slightly more efficient, but the other one, if it's making more sense to you, is completely effective and great. So I think method number one, as usual, my pen turned itself off, is going to just be to follow order of operations. And method number two is going to be multiply by 1 first to clear fractions. Okay, so I'll go through both methods on at least a couple of these, and maybe I'll just bounce back and forth a little after that. I encourage you to practice both. I'm not going to force you to do it one way or the other, but we really are trying to build up a set of algebra tricks that we're comfortable with, so practicing both is a really good idea. Okay, so first I want to do it with numbers, right? So we can connect back to what we did in chapter 1. And the order of operations way to do this would be to say, okay, well, we have our order of operations, and we want to make sure that we're walking through in the right order. So what I have here is a big division problem. The last thing that would happen in order of operations is this big fraction bar division right here. So the whole problem is a quotient, but remember your fraction bar is a grouping symbol. So especially that big one, we want to think about implied parentheses. So really the rule here, the order here would be to work inside the parentheses first and then do the division. And a lot of people mess up that order, and that's how they get these problems wrong. So remember, fraction bars are grouping symbols. Within the parentheses, we have addition subtraction problems. I'm going to erase those back off again so I can write next to it. So we will need addition, subtraction. You always need like terms. For fractions, that means the same denominator, so the pieces are the same size. So for the top, my least common denominator is 6, which means I'm going to be multiplying the first one by 3 over 3, and the second one by 2 over 2. I'm going to have to think about my naming of number 2, because really we are multiplying by 1 first here. So maybe we'll just call number 2 clear fractions first. That might make a little more sense as we get to it. So on the top we get 3 over 3, so we get 9 over 6, and then 2 times 2 is 4 over 6. It looks like in this problem, the LCD of the bottom is also 6, so we really just need to multiply that second fraction, top and bottom, by 3. So we'll have 5 over 6 plus 3 over 6. Now that we have the common denominators, we can do the addition subtraction. So 9 sixths minus 4 sixths is going to give us 5 sixths. And again, it is that idea of, think of it like this. I have 9 1/6, and I'm taking away 4 1/6, which leaves me with 5 of them. On the bottom, I have 5 of them, and I'm adding 3, so I'm going to get 8 sixths. Okay, so now everything in this problem is division. 5 divided by 6 divided by 8 divided by 6. So there's no more order of operations question. We can go straight to the division. Remember that dividing is always the same as multiplying by the reciprocal. So this will be 5 6 times 6 eighths, which is 5 eighths. And that's my final answer. I reduced before I multiplied, so I shouldn't have any reducing, and I don't. Okay, so let me show you the other way. And I think this way might look a little funnier with numbers. As we get variables in the mix, maybe it'll look a little bit more sensible, but it's nice even with numbers. So we're going to say, okay, starting from the beginning, 5 6 plus 1/2. you're going to find the LCD of all of the fractions within the big fraction. So it ends up being the same as above, but the top and the bottom could have different LCDs. In this one, we look at all 4 fractions. So we have halves, thirds, sixths, and halves. And when we look at all of those, the LCD is going to be 6. Instead of going through the addition and subtraction of fractions, we can take advantage of our multiply by 1 step in a different way. We can say, well, we have this big fraction bar. We could multiply the entire top by 6 and the entire bottom by 6. And since that still is multiply by 1, we won't be changing the value of our fraction. So it's a different way to use multiplying by 1. What's tricky here is we're going out of order of operations a little bit. So the first one is follow order of operations. Maybe that's a good way to talk about the second one. The second one is change the appearance. So we're kind of cheating and not doing the addition subtraction first because addition and subtraction of fractions is kind of a pain. Instead, we're getting rid of the fractions, then we'll do our addition subtraction. So it's really important in both methods that you remember these grouping symbols. In this one, it's because you need to distribute. So this one does require you to do some of this fraction arithmetic in your head, but it's multiplying instead of adding, subtracting, so that's nice. So we need to do 3 halves times 6. So however you do that, we'll say that's 18 over 2. If it helps, you can remember this is over 1, right? So we're multiplying by 6. We're not multiplying by 6 over 6. Here, I'm saying that, it's being confusing. In the top, we're multiplying by 6 and not 6 over 6. So 6 times 3 halves is 18 halves, which is 9. 6 times 2 thirds is 12 thirds, which is 4. On the bottom, 6 times 5 sixths is 5, and 6 times 1 half is 3. Notice this should look kind of familiar. Remember when we were counting up sixths before? We have that same arithmetic here. We've just kind of removed the sixes from the sixth. That has a TH in it if you can't hear it, from the problem. So now we're counting up wholes instead of sixths, and since we did it to the top and bottom, we should maintain the same value for our fraction. So 9 minus 4 is 5, and 5 plus 3 is 8, and we end up in the same place. And it saves us a little bit of fraction addition subtraction, and it also shortens this a little bit. Again, admittedly, the shortening is because we do some of that multiplication in our head. So maybe not really shorter, but it is a nice way to eliminate fractions instead of having to work with them for as many steps as we did in method 1. So both are really good. I want you to understand both. And I want you to practice both. Okay, so let's in this video at least get into some with variables. So this one, it's not too messy on the variables, but we do at least have some x's in it. So method number 1 says find the LCD. So it's basically perform the addition and subtraction first so that you can divide the fractions you end up with. So to perform addition subtraction in the top and bottom, we'll need to get LCDs. So in the top, 4 and 6, that's going to have an LCD of 12. So we're going to multiply top and bottom by 3 and top and bottom by 2. So we're going to get 3/12 plus 2x over 12. And then in the bottom, LCD is also 12. So the first fraction is fine. The second one needs to get multiplied by 4 over 4. X over 12 minus 4 over 12. Okay, again, we're kind of getting lucky. I'm imagining I have some later where this isn't true, but the top and the bottom don't have to have the same LCD. So if one was 12 and one was 6, that's totally fine for this method, just so that you're not worried about it. It's not going to hurt you if you make them all the same, but it's not a requirement. Okay, so when we add, this will look a little bit different because 3 and 2x are not like terms. So this is just adding rational expressions, which means basically mushing that into a single fraction. And then on the bottom, we'll have x minus 4 over 12. This is still better than where we were because now we can actually perform the division, right? So there is still addition, subtraction within some of our little fractions, but within our big fraction, it's just a fraction on the top divided by the fraction on the bottom. So 3 plus 2x over 12 should get multiplied by the reciprocal, which is 12 over x minus 4. The 12s will cancel, and I have 3 plus 2x divided by x minus 4. And you should always check and see if you can reduce. I reduced ahead of time, and I don't see that there's anything more I can do. Remember, you have to be able to cancel something out. That's a division. You have to be able to make that thing a factor first. So right now, the top's an addition, the bottom's a subtraction. We can't divide things out of sums and differences, not inverses. Okay, I'm going to do this one last one on this page, and then I'll give you a separate video. Oh, wait a minute. Getting ahead of myself. Let's do method number 2, which says, again, find the LCD. This time it does matter that it works for all of the fractions. Otherwise, you're going to have to do some extra steps. So not a big difference here. If I look at fourths, sixths, twelfths, and thirds, the LCD is still 12. Now we're going to multiply the big fraction top and bottom by 12 instead of multiplying the little fractions top and bottom to get 12 as their denominator. So again, this is where some stuff happens in our head. Make sure you distribute. That's really key. The failure point on this method is forgetting to distribute that through. And I would say it's really kind of the same for the last one. The failure point is to not recognize the top and bottom as grouped and to just flip the individual fractions on the bottom. So those grouping symbols are key. In the first one, they force you to do the addition subtraction first. In the second one, they force you to multiply everything by 12. So 12 times 1/4 is 3. 12 times x over 6 is 2x. This one's going to be really slick. 12 times x over 12 is just x. And 1/3 of 12 is 4. So this one, it looks really like it made it a lot nicer. Okay, at that point, I think I will actually cut and do the next one in a separate video. So thanks for watching.